Welcome to the Quirk Lab, where weird human habits meet hardcore science. You record a voice note, press play, and a stranger answers in your exact words. The pitch seems wrong, the rhythm feels awkward. Everyone else insists that is what you sound like. But that answer is only half true. The voice inside your head is not the whole truth, and neither is the recording. To understand the stranger, we have to separate at least 4 different versions of one voice. Version 1 begins at the source. Air from your lungs makes tissue in your larynx vibrate. Your throat, mouth, tongue, lips, and nasal passages reshape that buzzing into speech. This is the acoustic signal leaving your mouth. Version 2 is what another person receives. Your voice travels through the room, reflects from walls, bends around your face, and enters their particular ears. Their brain then turns that changing pressure into a recognizable speaker. Version 3 is what you hear while you speak. It contains some of that outside, air-conducted sound, but it also contains vibration traveling through tissues and the structures of your head toward the inner ear. Version 4 is the recording. Whatever one microphone captured, stored, and whatever one speaker or pair of headphones rebuilt later. Those 4 signals are related. They are not identical copies. When somebody else talks, sound mainly reaches you through the air. When you talk, your entire vocal system is already vibrating. Some energy reaches the inner ear through pathways involving bone and soft tissue. That extra route changes the mixture you have heard every day of your speaking life. The popular explanation says bone conduction simply adds bass, making your internal voice deeper and richer. That can be a useful first approximation, but it is not a universal equalizer preset. In an acoustic study of 10 phonemes, the balance between air and bone-conducted components changed with the sound being produced, and the bone-conducted component often dominated between 1 and 2 kilohertz. Different vowels and consonants create different patterns. So your skull is not turning one clean studio track into the same track with the bass knob raised. Your anatomy is part of a complicated personal transfer path. Remove that path during playback, and the spectrum no longer matches your familiar version. Frequencies may feel exposed. The voice may seem thinner, sharper, or simply misplaced. And because skulls, tissues, vocal tracts, and listening histories differ, there is no single filter that reconstructs everyone's internal voice. One small experiment makes that individuality visible. Researchers let 10 participants compare unmodified recordings with several filtered and personally adjusted versions. 8 preferred some modified version as more self-like, but the winning modification differed from person to person. 2 actually chose the plain recording. The internal voice is not one standardized effect. Now for the second myth, the recording is exactly what everyone else hears. It is closer because both a microphone and another listener receive air-conducted sound, but closer is not identical. A microphone samples pressure at one location. Move it closer and it captures a different balance of direct voice, breath, and room reflections. Change its direction, hardware, or automatic processing, and the result changes again. Then the file travels through a phone speaker, laptop, earbuds, or studio headphones, each rebuilding the signal differently. Another person's hearing has its own geometry and neural processing. A phone microphone is not shaped like their outer ears. A tiny phone speaker is not your mouth. The room where you record may not be the room where they normally hear you. Try a controlled version yourself. In one quiet room, record the same sentence on the same device, first close to the microphone and then at arm's length. Keep your speaking effort as steady as you can. Compare both recordings through the phone speaker and through headphones. You will probably hear several noticeably different U's, even though your larynx did not transform between takes. That demonstration does not reveal a hidden authentic setting. It reveals the chain. Acoustics explains why playback sounds different. It does not fully explain why the difference can feel so personally wrong. Speaking is an action, not a sound that happens to you. When the brain sends motor commands to produce speech, it also prepares for the expected sensory result. Scientists call the accompanying signal a corollary discharge. Think of it as a forecast attached to the command. I am about to make this sound. Across many experiments, the auditory cortex responds less strongly while a person speaks than when the same sound is played back. This is called speaking-induced suppression. The brain is not muting your voice. It is reducing the surprise of a predicted, self-generated event so unexpected sounds can stand out. In a 2024 study, researchers recorded directly from the cortices of 8 neurosurgical patients. Across several speech tasks, they found communication from ventral speech motor cortex toward auditory cortex that peaked before articulation. The strength of that signal predicted how much the auditory response was suppressed. 8 clinical participants cannot represent every brain, and electrodes were placed for medical reasons. But the timing gives unusually direct evidence for a speech forecast arriving before the sound. During ordinary speaking, that forecast lines up with moving articulators, vibration in the head, and air-conducted sound. During playback, you are not issuing the same motor command. The voice arrives as an external event. One component of "this is me" is missing. This helps explain a strange result. Adding vibration can improve recognition of your own recorded voice. In 3 studies, researchers blended each participant's voice with other voices and asked which person dominated the mixture. They presented the sounds either through ordinary air conduction or with bone-conducted vibration. The studies included groups of 16, 16, and 52 participants. Bone conduction improved self versus other discrimination, but it did not produce the same benefit when the task was merely distinguishing a familiar person's voice from an unfamiliar one. That suggests vibration is not just making every voice clearer. It supplies a cue that belongs especially to the learned experience of one's own voice. The task was still difficult. In a control test from the largest study, participants correctly labeled their unmodified voice as self on about 79% of trials. Yet they sometimes called a familiar person's voice their own, and sometimes did the same with an unfamiliar voice. 9 of the 52 participants recognized their own unmodified recording on fewer than half the self-voice trials. That does not mean those participants had a disorder. It means self-recognition from air-only recordings is less automatic than it feels like it should be. And the system is flexible. In another experiment, 93 women spoke while hearing real-time feedback that could be replaced by a stranger's voice. When the feedback matched the timing and phonetics of their own speech, some participants partially attributed that stranger voice to themselves. The brain combined action and matching sensory timing into a temporary sense of ownership. Your voice identity is not stored as one audio file. It is assembled from sound, vibration, action, timing, and familiarity. So why do many people jump from unfamiliar to awful? Here, the evidence is less tidy. A mismatch can create surprise, and surprise invites inspection. You suddenly notice a nasal resonance, a pause, a laugh, or a regional accent that your predicted voice normally hides in plain sight. Because the speaker is you, those details can feel like information about identity rather than ordinary acoustic variation. But unfamiliar is not a scientific synonym for unattractive. Your friends are not comparing the recording with the private voice in your head. They learned your air-conducted voice as the normal one. The feature shocking you may be completely unremarkable to them. A 2024 study of 176 Arabic English bilingual participants found that higher social anxiety symptoms were associated with greater dislike of one's recorded voice, especially in the first language. The design was cross-sectional, so it cannot tell us which came first, and it cannot diagnose anyone who cringes at a voice note. Most important, discomfort with a recording is not by itself evidence that anything is wrong with your voice or your mental health. Previous exposure also matters for recognition. In the bone conduction experiments, hearing the unmodified recording before the discrimination task improved performance. For anyone who repeatedly monitors recordings, playback is at least no longer a rare visitor. But that experiment measured recognition, not whether people learned to like the sound. Practice can make a signal familiar. It does not turn it into the only true signal. Now we can answer the question behind the cringe. Is the voice in your head real? Yes. It is the real sensory experience of producing speech through air, tissue, vibration, and prediction. It is just private. Is the recording real? Also yes. It is a real capture made by a particular microphone in a particular room and reconstructed by a particular playback system. It is just conditional. Is it what other people hear? It is usually closer to their input than your internal voice is because it excludes your private bone and tissue pathway. But another person's ears, position, room, attention, and brain are not the recording chain. In everyday conversation, they often also have your face, gestures, timing, and context. Human listeners do not experience you as a detached waveform from a phone speaker. The best answer is that a voice is not a fixed object. It is an event moving through a system. Change the path and you change the version. That matters if you make videos, sing, give presentations, or send voice notes. Judge recordings under consistent conditions. Use the same microphone distance and listening device when comparing takes. Focus first on whether the words are clear and the delivery fits the message. Do not treat the first startling playback as an objective verdict on how every person experiences you. The stranger in your recording is not an imposter, and it is not the single unfiltered truth that everyone else has secretly known. It is your voice after one familiar pathway has been removed and several new filters have been added. Inside your head, sound is fused with vibration and the motor forecast that produced it. Outside your head, a microphone captures one slice. A playback device builds another. Your brain compares that result with a lifetime model of me and notices the gap. That gap is the quirk. The stranger is still you, just you, traveling by a route you rarely hear. Thanks for watching. If you enjoyed exploring the science behind everyday quirks, subscribe to the Quirk Lab, and I'll see you in the next one.